What is cos x plus y formula? Cos x cos y minus sin x sin y. If you take the right hand side of 1 minus tan square x by 1 plus tan square x, on solving this, you will get back the cos 2x. What is the formula for sin 2x? It is 2 sin x cos x. So if you got 2 sin x cos x, replace with sin 2x. So cos 2x is nothing but cos square x minus sin square x. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysore. In our previous session, we have learned all those informations about trigonometric ratios and also sum and difference of their angles. So in today's session, we'll be dealing with multiple angles, submultiple angles and transformation formulas. But submultiple angles is not in your syllabus for your trigonometry, but it is sake for your reference. So mainly concentrate on multiple angles and transformation formula. So what do you mean by this multiple angle? You have already learned the formula of cos x plus y in terms of different angles. There you have for example, suppose you have cos 75 degree, you would have taken it as cos 45 degree plus 30 degree. So there you have used the formula of cos x plus y formula. What is cos x plus y formula? Cos x cos y minus sin x sin y. So if you apply here, this becomes cos 45 cos 30 minus sin 45 sin 30. So to find the value, any value or any angle expressed in terms of sum or difference of standard angles. So therefore, cos 45 is 1 by root 2, cos 30 is root 3 by 2, sin 45 is 1 by root 2, sin 30 is 1 by 2. So when you solve this, you will get the answer as root 3 minus 1 because the denominator is 2 root 2. That is same. So your answer for cos 75 is root 3 minus 1 divided by 2 root 2. What happens if x and y are same? There you will get the multiple angles. For example, cos x. Just replace y with x. What happens? X plus x is cos 2x. So any angle multiplied with 2, 3 or any integral values, they are called as multiple angles. For example, 2x, 4x, 3x, like this. And we come across an angle like half x. So here it is nothing but x by 2. So this is your submultiple. So they are called as multiple angle. They are called as submultiple angles. For example, you may get the fraction as x by 4, x by 6 like this. So these are all called as submultiple angles and these are called as multiple angles. Today we will prove all those multiple angles of cos, sin and tan with the use of cos x plus y formula. Here we have cos 2x is equal to cos square x minus sin square x. Also it is equal to 2 cos square x minus 1. Also it is equal to 1 minus 2 sin square x 1. Also it is equal to 1 minus tan square x by 1 plus tan square x. How will get that? I said you can use the formula of cos x plus y. So let me use now. We know the formula of cos x plus y, which is nothing but cos x cos y minus sin x sin y. So what happens here? Just replace y by x. First I am solving these two equalities, that is cos 2x is equal to cos square x minus sin square x. So now just replace x with y. So x plus x is equal to cos x minus sin x sin x. So what is this? Cos x into cos x, cos square x, sin x into sin x, sin square x. So which is here your cos 2x formula. So this is one of the identity of multiple angles of cos 2x. So cos 2x is nothing but cos square x minus sin square x. Now I'll be proving this. So this can be derived from this identity. How? What is the relationship between sine and cos? We know that sine square x plus cos square x is equal to 1. So if you convert this, sine square x can be written as 1 minus cos square x. Similarly, cos square x can be written as 1 minus sine square x. So here in this formula, cos 2x, I have cos square x here minus, instead of sine square x, I'll replace with 1 minus cos square x. So you have 1 minus cos square x. Now what happens? Cos square x, multiply minus inside, so it becomes cos square x. Cos square x plus cos square x is 2 cos square x minus 1. So this is your second proof. So cos 2x can also be written as 2 cos square x minus 1. Now I'll take the third one. So now I'm going to prove cos 2x for 1 minus 2 sine square x. What is the basic formula we got? That is cos 2x is equal to cos square x minus sine square x. So instead of cos square x, replace it with 1 minus sine square x minus sine square x. So now we will get 1 minus sine square x, 2 sine square x. So this is one more identity of cos 2x. Next I am going to prove this one, that is 1 minus tan square x. So here I am considering your right hand side part. So let me take your right hand side part. I'll take this as left hand side and this as your right hand side. So what does right hand side contains? 1 minus tan square x by 1 plus tan square x. Now, what is the relationship between tan? Whenever you get a tan function, just replace with sine by cos, because tan function is the reciprocal or it is the ratio of sine and cos. So therefore, 1 minus sine square x. Why sine square here? Because we have tan square there. So sine square x by cos square x whole divided by 1 plus sine square x divided by cos square x. On evaluating this numerator and denominator in terms of fractions, we will get cos square x minus sine square x whole divided by cos square x whole divided by, this is cos square x plus sine square x whole divided by cos square x. We can cancel the denominator because it has the same denominator. And what is this actually? Your cos square x plus sine square x, the value is 1. So this is equal to 1. So the denominator is completely 1. Anything divided by 1 is same as the numerator. This is your cos square x minus sine square x. But what is this cos square x minus sine square x? Look here. It is your cos 2x. So, which is equal to your LHS. So, this is how we can prove any identity of cos 2x. So, all cos 2x can be written in 4 forms. One is cos square x minus sine square x. The other one is cos 2 cos square x minus 1. How you will get this? Just replace sine square x by 1 minus cos square x. If you replace cos square x by 1 minus sine square x, you will get the third identity. And if you take the right hand side of 1 minus tan square x by 1 plus tan square x, on solving this, you will get back the cos 2x. We can also prove from LHS to RHS, but this is the easiest method. So if you take the RHS first, we can get LHS easily. Next one, how we have to prove the functions of cos 2x. In the same way, sin 2x can also be proved. So look here, we have sin 2x. We have two formulas for sin 2x. One is 2 sin x cos x and the other one is 2 tan x by 1 plus tan square x. Let me prove it. How I'll get sin 2x is equal to 2 sin x cos x. We know the formula of sin x plus y. So you should learn all the sum and difference of cos x plus y, cos x minus y, sin x plus y, sin x minus y. Similarly for tan. Cot is not so necessary. So just remember it for the sake of your knowledge. Now, sine 2x. We know the formula of sine x plus y. What is sine x plus y? Sine x cos y plus cos x sine y. Same as we did it for cos 2x formula. Replace y by x. What happens if I replace y by x? Here x plus x becomes sine 2x. Now this is your sine x. And here it is cos x plus cos x and sin x. You have sin x cos x plus sin x cos x, which is nothing but 2 sin x cos x, which is your first identity. How will we get this? So, we can take sin 2x as 2 tan x by 1 plus tan square also, or we can prove from right hand side to left hand side also. I'll take the right hand side part. So, let me take your right hand side part here. That is 2 tan x divided by 1 plus tan square x. So, whenever you get tan, replace with sin by cos. So, it is 2 sin x by cos x whole divided by 1 plus sin square x by cos square x, because you have tan square x there. Now, here write as it is 2 sin x by cos x whole divided by, so this becomes cos square x plus sin square x whole divided by cos square x. So this value will become 1 because a square plus b square, that is sin square x plus cos square x, is here 1. Here cos x get cancelled, 1 cos x get cancelled, it goes to the numerator. So what happens? This is 2 sin x cos x, which is your sin 2x formula, isn't it? What is the formula for sin 2x? It is 2 sin x cos x. So, if you got 2 sin x cos x, replace with sin 2x. Now, we have proved this, that is sin 2x is equal to 2 sin x cos x. Also, it is equal to 2 tan x divided by 1 plus tan square x. Now, the next one is tan 2x. How we will get this? Using the formula of tan x plus y. What is the formula of tan x plus y? So, tan x plus y is tan x plus tan y divided by 1 minus tan x tan y. So, the same application, replace y by x. So, tan x plus tan x whole divided by 1 minus tan x tan x. Now, what is tan x? Tan x? 2 tan x. What is tan x into tan x? Tan square x. So, remember x plus x is 2x. X into x is x square. Most of you will confuse it with x plus x as x 2x, and x into x also you will write it as 2x, but it is wrong. X into x is x square. So, tan x into tan x is tan square. It is not tan 2x. So, thus we have proved this. So, tan of x plus y can be written as 2 tan x 1 minus tan square x. Why can't we use tan x minus y formula? Because if you replace y by x, it becomes tan x minus x, which is 0. So, therefore, I can use only tan x plus y formula. So, next type of problems which carries 3 marks for your examination purpose. All these identities of multiple angles may carry 2 or 3 marks questions for your examination. So, very simple problems, you can easily derive it. Now, you have to take sine 3x. I doesn't know what is sine 3x, but I know what is sine 2x. So, what I'll do here is sine 3x can be written as sine 2x plus x. Again, what is the formula for this? This looks like sine x plus y. Remember, what is the formula for sine x plus y? Sine x plus y, it is sine x cos y plus cos x sin y. Now, I'll apply the same concept here. In the place of x, you have 2x. In the place of y, you have x. Just replace it. What happens here? It is sine 2x cos x plus cos 2x sin x. Now, whatever you get here in terms of cos, replace it with sine only, because observe your right hand side, all sine 3x is in the form of sine only. So, if you got cos also, you can convert this into sin x. Now, what is your sine 2x? We know the formula of sine 2x. What is the formula for sine 2x? It is 2 sin x cos x, which we have proved earlier. So, 2 sin x cos x into one more cos x we have here. Again, what is cos 2x? Now I said you have sin x here, cos 2x, we have 4 identities. In that 4 identities, you choose cos 2x formula in terms of sine. What is the formula in terms of sine? That is 1 minus 2 sine square x. So you can choose the identity for your requirement. So here I can replace with 1 minus 2 sine square x into sin x. So these are all the formulas. Now multiply. We have 2 sin x here. Cos x into cos x is cos square x. When you multiply this, 1 into sin x is sin x minus 2. Sin square into sin is sin cube x. Again we have here cos square x. Replace with sin. How? Cos square x can be written as 1 minus sin square x. So therefore here 2 sin x can be written as 1 minus sin square x plus sin x minus 2 sin cube x. So therefore multiply now 2 sin x into 1, 2 sin x. We have minus 2, we have sin x into sin square, sin cube x plus sin x minus 2 sin cube x. Now 2 sin x plus 1 sin x is your 3 sin x. Next 2 sin cube x, 2 sin cube x is 4 sin cube x. You have negative sign there. So this is your identity for sin 3x formula. So you have just taken sin 3x as the sum of 2x and x. Apply sin x plus y formula. You will get the result like this. Replace all cos x in terms of sin x only. So therefore, when you got cos 2x, you are replacing it with 1 minus 2 sin square x. When you got cos square, you are replacing with 1 minus sin square x, so that after solving, all the terms will come in terms of sin only. So the sin 3x is nothing but your 3 sin x minus 4 sin cube x. Again, the very important identities, learn all those identities, whatever you will get in trigonometry, because it is very helpful in your limits and calculus part in your second PUC. So the next part is prove that cos 3x is equal to 4 cos cube x minus 3 cos x. So again, a question for 3 marks question. Okay, I'll take cos 3x. Same application as sin 3x. What we did? Sin 3x as sin 2x plus x. So this is now cos 2x plus x. Now this is in the form of cos x plus y formula. Apply the formula of cos x plus y, where x value is 2x, y value is x. So which is nothing but cos 2x into cos x minus sin 2x into sin x. Now look at your RHS side. All the terms is in cos function only. So whenever you get sin, convert it into cos. So now cos 2x can be written as 2 cos square x minus 1. Don't use cos square x minus sin square x. So here you need only cos function. So substitute all the terms with cos only. So cos x minus here it is 2 sin x cos x into sin x. Now when you multiply this, this becomes 2 cos cube x minus cos x minus 2 sine square x into cos x. Again you got sine square, replace with 1 minus cos square x there. So this is equal to 2 cos cube x minus cos x minus 2 into 1 minus cos square x into cos x. So now you got 2 cos cube x minus cos x. Here leave this minus, multiply 2 into 1, 2. 2 cos x, it is minus 2 cos x. Minus into minus plus, you have 2 cos square x into cos x is 2 cos cube x. 2 cos cube x plus 2 cos cube x is 4 cos cube x. Minus 1 minus 2 is minus 3 cos x. So this is what we need to prove. That is cos 3x is 4 cos cube x minus 3 cos x. So whatever the multiple angle given, whether it is in a 3x or 5x or 10x or 12x, anything, it can be expressed as a sum of any two values of the same function. Since we know the identities of cos 2x now we know the identity of cos 3x also. We can use all these identities to calculate more multiple angles. Next we have tan 3x is equal to 3 tan x minus tan cube x 1 minus 3 tan square x. Again, we know the formula of tan x plus y. So let me see what is your tan x plus y. Your tan x plus y formula is tan x plus tan y whole divided by 1 minus tan x into tan y. So this is your formula. Why I am writing this? I'll let you know now. Tan 3x can be written as tan 2x plus x. So use the formula now. In the place of x you have 2x. In the place of y you have x. So this will become tan 2x tan x whole divided by 1 minus tan 2x into tan x. Replace tan 2x formula. Tan 2x is 2 tan x 1 minus tan square x. So just replace it. 2 tan x 1 minus tan square x plus tan x whole divided by 1 minus 2 tan x divided by 1 minus tan square x. Write it in a bracket because this is a multiplication. Next, solve this. So in the numerator you have 2 tan x. Cross multiply with these two. So you will get plus 1 minus tan cube x whole divided by 1 minus tan square x whole divided by, I am just solving only the numerator part here. Now coming to the denominator part, just cross multiply this. You will get 1 minus tan square x. Multiply these two. This is minus 2 tan square x. Again whole divided by 1 minus tan square x. Numerator and the denominator part have the same denominator. So cancel it. Now just see here. So you got it as 2 tan x plus, when you multiply this, this becomes tan x. So plus tan x, because tan x into 1 is tan x. Tan x minus tan x square is minus tan cube x. So now 2 tan x plus tan x is 3 tan x. And you have tan cube x there. Whole divided by, here in the denominator you have 1, write 1. Minus tan square x minus 2 tan square x becomes minus 3 tan square x. So this is your right hand side part. So tan 3x is 3 tan x minus tan cube x divided by 1 minus 3 tan square x. Next we come across submultiple angles, but it is not in your syllabus, but the knowledge of submultiple angles is very necessary for your calculus part. Now, how we will get the submultiple angles? I'll just explain only with two formulas. We know sine 2x formula. What is it? 2 sin x cos x. If I replace x, 2x as some term a. I'll take 2x as a. Then what is your x? A by 2. So wherever you will get 2x, replace with a. Wherever you will get x, replace with a by 2. So what happens now here? Sin a is equal to 2 sin a by 2 cos a by 2. This is what your submultiple angle. The same formula with 2x as a and x as a by 2. Similarly, we can show for cos 3x also. We know cos 3x is equal to 4 cos cube x minus 3 cos x. Okay, so what is 3x? Suppose you take 3x as some theta. Then what is your x? It is theta by 3. So replace it. So therefore, cos theta can be written as 4 cos cube theta by 3 minus 3 cos theta by 3. So the same formula in terms of fractions. They are called as submultiple angle. So we will be using this in differentiation and integration wherever it is necessary. So it is not in your first PUC syllabus. Very useful for second year syllabus. Next, we come across a very important formulas, that is transformation formula. All your 5 marks question in your trigonometric chapter carries the application of these transformation formula. Again, no proof in your syllabus, just learn the identities. How we got this? We got with the same cos x plus y formula, sin x plus y formula. So I'll show the proof of any one of this, but the proof is not necessary for your syllabus. Learn the formulas for the problem part. Now here is the transformation formula. Sum and difference to product. So any sum of, the sum of any functions like cos x and cos y, there are two different functions with two different values. Cos x plus cos y is equal to 2 cos x plus y by 2 cos x minus y by 2. Similarly, cos x minus cos y, difference of two cos function is nothing but the product of sine in terms of sine x plus y by 2, x minus y by 2. Sine x plus sine y is 2 sine x plus y by 2 cos x minus y by 2. Sine x minus sine y is 2 cos x plus y by 2 sine x minus y by 2. How we'll get this? So let me take now, let me prove the first one here, that is cos x plus cos y. As we have taken previously, some 2x is equal to a, some 3x is equal to theta. The same application I'll do here. We know the formula of cos x plus y. Similarly, we know the formula of cos x minus y. Okay. So this I have taken. What is the formula of cos x plus y? Cos x cos y minus sin x sin y. Plus, what is cos x minus y formula? Cos x minus y is cos x cos y plus sin x sin y. So look here, minus sin x sin y plus sin x sin y get cancels. What I'll get here? 2 cos x cos y. Now here you can see the sum of two function is expressed as product of two functions. So this is what the transformation formula. Sum or difference to product or product to difference. So now how we got this? Ma'am, here we have only x, but there you have taken x plus y. Very simple. We have taken in the form of submultiple angle. So now x plus y I'll replace with some term a. And x minus y I'll replace with b. Then 2 cos. If I take x plus y as a, then what is my x? So it is in the form of x plus y by 2. Similarly, what is my y? It is in the form of x minus y by 2. So here we have taken the sum of two functions as converted into product of two functions. So the same can be taken for all sine as well as cos. We can apply for tan and other function also. But basically learn these 4 transformation formula of sum or difference to product. Next, as I said, we have product to difference also. The same formula here it has taken as cos x plus cos y. Now we are getting back from here to here, RHS to LHS. So here, this one I have taken as X, this one I have taken as Y. So this will become your X plus Y by 2 and this will become your X minus Y by 2. This 2 will come in the denominator. Back to the formula. From LHS to RHS, it is sum to product or difference to product. The same is from product to sum or difference. Look here, 2 cos x cos y can be taken as cos x plus y cos x minus y, as I did it previously. Here, cos x plus y cos x minus y means 2 cos x cos y. You can go back. From here to here, it is sum to product, and from here to here, it is product to sum. So if you learn all these formulas, transformation formula, we are transforming sum or difference to product, product to sum or difference. So therefore, it is called as transformation formula. Again, I am telling you, very important identities you should learn for the purpose of your 5 marks question in your examination. Again, minus 2 sin x sin y. When you add cos function, subtract with cos x minus function, you will get it as minus sin x sin y minus sin x sin y, which is minus 2 times sin x sin y. Similarly, when you add these two functions, you will get this. When you subtract these two functions, you will get this. So this is how we will convert the product of two functions into sum or difference of two functions in terms of sine and cos. Yes, in today's session, we have discussed basically on multiple angle formulas and transformation formulas. Multiple angle formulas can be asked in the form of prove that questions, which may carry 3 marks in your examination. And transformation formulas, learn all those formulas because it is very important for 5 marks question in your examination. So 5 marks from trigonometry carries the problem from transformation formulas. In the next session, we'll be taking the problems based on and using all these identities. So till then, keep watching, keep learning and keep exploring. Thank you.